All right, so to finish up this section, we're going to cover example 2 from the book. So in example 2, they want us to show that a function f of x, which equals cosine squared of x minus 2 sine of x over 4, has a 0 in 0 to 2. And then we want to use the bisection method to locate the 0 more accurately. So use bisection method to locate the 0 more accurately. So basically, we're going to get, the bisection method says we're going to get, we know the 0, we'll find the 0 in 0 to 2, then we'll cut that interval 0 to 2 in half, and the 0 will have to be on one or the other side. And then we'll figure out which side it's on, and then we'll cut that side in half, and then we can keep going. So we'll probably stop there in the example, but we'll keep going. You say, well, then you can cut that in half and figure out where the 0 is, cut that interval in half, and we would just go with smaller and smaller intervals, and we can find the 0 in a tighter and tighter open interval, which would find it more accurately. So we're going to use our corollary, which says, okay, we know f of x, this is built up of cosine, so it's cosine squared, it's cosine times cosine, that would be continuous. Sine of x over 4, that's continuous, multiplying it by 2 is continuous, and continuous minus continuous is continuous. So we know f of x is continuous on, it's going to be continuous on 0 to 2. It's continuous everywhere, but specifically 0 to 2. So we know we can apply that corollary. Well, we hope we can find the corollary. So let me load my, make sure if you guys are doing this, make sure you're in radian mode so that your trig functions are in terms of radians. And then I'm going to load this function into my calculator. So I'll get cosine of x squared minus 2 sine of x over 4, because that's going to make it a lot easier for me to figure out the y values at some of these. So we'll say, all right, what is f of 0? F of 0 is 1. And then we'll say, all right, what's f of 2? F of 2 is negative 0.7857. So this is continuous. F of 0 is positive, f of 2 is negative, so these have opposite signs. So then by our corollary, f of x has a 0, in 0 to 2 by corollary. And so we said, okay, we proved that there's a 0 there. We don't know exactly where it is, but we know it's in 0 to 2. So now what we'll look at is f of 1. So f of 1 is equal to negative 0.2029. So basically, we're going to look at 0 to 1, interval 0 to 1, and then we'll look at the interval 1 up to 2. Well, f of 0 is 1, f of 1 is negative 2, so there's a sign change from 1 to negative 2. So these have different signs, which means the 0 is going to have to be here. F of 1 is negative, f of 2 is also negative, so negative to negative doesn't force the function to pass through the 0, so this interval is out. So now we can say, so f of x has a 0 in 0 to 1 by the corollary. So we said, okay, 0 is 1, f of 1 is negative 2. So we're going to look what's halfway between 0 and 1. So we'll look at what is going on with f of 1/2. So we'll put in f of a half, and we get positive 0.5208. So I found that my zeros now is in the region 0 to 1. I'm going to split that interval in half and look at 0 up to a half and a half up to 1. And I'll say the zero's got to be in either 0 to a half or a half to 1. And how do I know which side it's in? Well, I look where the sign changes. 0, f of 0 is 1. F of a half is positive 0.208. So these are both positive. So the 0 is not in this interval. F of a half is positive 0.5208. F of 1 was negative 0.2029. So there is a sign change between a half and a 1, which says the 0 is in this interval. So f of x has a 0 in the interval 1/2 up to 1 by the corollary. And we're going to stop there, but because we located it more accurately. We initially had it in an interval of length 2. We cut that interval in half, and we found it was in this interval of length 1. And then we cut that interval in half and said, okay, which side is it on? Here's the side with the sign change. So we said now it's in this interval that's half a unit long. We could cut this interval in half and see where it is, and then cut that interval in half, and cut that interval in half, and we could keep going and going and going until we get this in as tight of an interval as we want. And that's kind of the bisection method. Says use that corollary along with just cutting intervals in half each time. It didn't tell us where to stop. It just said find it more accurately. And here we found it more accurately. The next cut would be look at f of 3/4, see whether it's positive or negative, and then compare it with the endpoints and look for the sign change. And then we would just keep going from there. So we will stop there for 2.8.